The realm of quantum mechanics has always held an aura of mystery. It's a world where the impossible becomes possible, where particles can be in two places at once, and where information can seemingly travel faster than the speed of light. For decades, the concept of quantum teleportation has been relegated to the realm of science fiction. But now, scientists have achieved a groundbreaking feat. They have successfully teleported quantum information over ordinary internet cables. This breakthrough has the potential to revolutionize our world. This isn't teleportation in the Star Trek sense. We aren't beaming people or objects across vast distances. Instead, it's the teleportation of information. And that in itself is a revolution. Imagine a world where communication is instantaneous and unhackable, where sensors can detect the slightest changes in the environment with unprecedented accuracy. This is the promise of quantum teleportation. This breakthrough was achieved by a team of researchers at Northwestern University, led by Professor Prem Kumar. They were able to transmit quantum information over a 30-kilometer fiber optic cable. This cable was already carrying standard internet traffic. This is a significant achievement because it demonstrates that quantum communication can coexist with our existing infrastructure. The implications of this discovery are far-reaching. It could lead to the development of a quantum internet. This quantum internet would be exponentially faster and more secure than our current internet. It could also revolutionize fields like medicine, materials science, and artificial intelligence. We are on the cusp of a new era, an era of quantum possibilities. Quantum teleportation. The very name evokes images of futuristic worlds. But what is it really? In essence, it's the transfer of quantum information. This information is held in the state of a particle. It's transferred from one location to another, without the particle itself physically traveling between the 2 points. Think of it like this. Imagine you have a coin that's both heads and tails at the same time. This is the strange world of quantum mechanics. Now imagine you want to send the state of that coin, not the physical coin itself, but the information of its heads-tails state, to a friend miles away. You could describe it over the phone, but that wouldn't convey the true quantum nature of the coin. Quantum teleportation allows you to do just that. It allows you to transfer the exact quantum state of the coin. This is done without ever physically sending the coin. This is possible because of a bizarre quantum phenomenon called entanglement. Entanglement is a strange link that can exist between two particles. It allows them to share the same fate, even if they are separated by vast distances. This link is what enables the transfer of quantum information. Quantum teleportation doesn't violate the laws of physics. It doesn't allow for faster-than-light communication. This is because the process still requires a classical communication channel. This channel is used to send some additional information. Entanglement. Even Einstein had trouble wrapping his head around it. He famously called it spooky action at a distance. And spooky it is. Entanglement is a quantum phenomenon where two particles become linked. This link is so strong that they share the same fate, no matter how far apart they are. Imagine two coins flipping in perfect unison. One lands on heads, the other on tails. But here's the catch. You don't know which coin is which until you look at one. The moment you observe one coin and see heads, you instantly know the other is tails. This is the essence of entanglement. In the quantum world, these coins are particles like photons or electrons. When entangled, they share a single quantum state. This state describes their properties like polarization or spin. Measuring one particle instantly determines the state of the other, even if they are light years apart. This spooky action happens instantaneously. It seems to violate the speed limit of the universe, but it doesn't. This is because no information is actually traveling faster than light. The act of measurement doesn't create the information. It simply reveals what was already there. Entanglement is the key to quantum teleportation. It allows for the transfer of quantum information between entangled particles. This is done without the particles themselves physically traveling the distance. The recent breakthrough in quantum teleportation over internet cables is a testament to human ingenuity. It's a delicate dance of cutting-edge technology and mind-bending quantum mechanics. So, how did they do it? The team at Northwestern University utilized existing fiber optic cables. These cables are the backbone of our internet. They used a technique called frequency multiplexing. This allowed them to send quantum information alongside classical internet data, without any interference. The process begins with the creation of entangled photon pairs. These photons are like tiny packets of light that are linked together in a spooky quantum embrace. One photon from each pair is sent down the fiber optic cable. The other is kept in the lab. At the receiving end, a clever trick is employed. The incoming photon carrying the quantum information is measured along with a second entangled photon. This measurement doesn't reveal the information directly. Instead, it transfers the quantum state onto the second photon. This photon is still entangled with its partner back in the lab. This final photon now carries the teleported quantum information. It can be measured to reveal the original information. Voila! The information has been teleported. The key to this breakthrough is the ability to use existing fiber optic infrastructure. This makes quantum communication more practical and scalable. Section 5. The future is now. Implications for technology. The successful teleportation of quantum information over internet cables is not just a scientific curiosity, it's a game changer. It has the potential to revolutionize a wide range of technologies. Imagine a world with unhackable communication networks. This is the promise of quantum cryptography. Quantum information cannot be copied or intercepted without detection. This makes it ideal for secure communication. The sensitivity of quantum systems also opens up new possibilities for sensing and measurement. Imagine medical sensors that can detect diseases at the cellular level, or environmental sensors that can monitor pollution with unprecedented accuracy. Quantum teleportation could also pave the way for quantum computing on a global scale. Quantum computers can solve certain types of problems exponentially faster than classical computers. Connecting them via a quantum internet could unleash unprecedented computing power. This breakthrough is a crucial step towards realizing these transformative technologies. It brings us closer to a future powered by the strange and wonderful laws of quantum mechanics. Section 6. A quantum leap for communication. Communication is the lifeblood of our modern world. From the internet to mobile phones, we rely on the rapid and reliable exchange of information. Quantum teleportation has the potential to take communication to a whole new level. Imagine a world where communication is perfectly secure, where it's impossible to eavesdrop on a conversation or hack into a network. This is the promise of quantum cryptography. Quantum cryptography exploits the principles of quantum mechanics to create unbreakable encryption keys. These keys can be used to encode and decode messages. Any attempt to intercept the key would disturb the quantum state. This would alert the sender and receiver to the intrusion. The recent breakthrough in teleporting quantum information over existing fiber optic cables is a major step towards making quantum cryptography a reality. It paves the way for the development of a quantum internet. This quantum internet would be exponentially more secure than our current internet. This technology could revolutionize fields like finance, healthcare, and government. It would allow for the secure transmission of sensitive data. It would protect against cyber attacks and espionage. Section 7. Beyond the lab, real-world applications. The implications of quantum teleportation extend far beyond the laboratory. It has the potential to revolutionize a wide range of industries and aspects of our daily lives. In medicine, quantum sensors could lead to earlier and more accurate diagnoses. Imagine detecting cancer cells before they form tumors, or monitoring brain activity with unprecedented precision. Environmental monitoring could also benefit greatly from quantum technologies. Quantum sensors could be used to detect pollutants in the air and water with greater sensitivity. They could also monitor deforestation and climate change with greater accuracy. In manufacturing, quantum sensors could be used to improve quality control and detect defects in materials. This would lead to the development of safer and more reliable products. The possibilities are truly endless. As our understanding of quantum mechanics grows, so too will the potential applications of this groundbreaking technology. Section 8. The Next Frontier Future Research Directions. The successful teleportation of quantum information over internet cables is a remarkable achievement, but it's just the beginning of a long and exciting journey. Researchers are already working on the next generation of quantum technologies. One area of focus is extending the distance over which quantum information can be teleported. Currently, the record stands at 30 kilometers. Researchers are working on extending this to hundreds or even thousands of kilometers. Another area of research is improving the efficiency and reliability of quantum teleportation. Currently, the process is still relatively slow and error-prone. Researchers are working on developing new techniques and materials to improve the fidelity of quantum communication. The ultimate goal is to build a global quantum internet. This network would connect quantum computers and other quantum devices around the world. It would enable the development of powerful new applications in fields like medicine, materials, science, and artificial intelligence. The future of quantum technology is bright. With each breakthrough, we move closer to unlocking the full potential of this revolutionary technology. Section 9 Conclusion. Ushering in a new quantum revolution. The world is on the cusp of a new technological revolution, a revolution driven by the strange and wonderful laws of quantum mechanics. The successful teleportation of quantum information over existing internet cables is a major milestone in this revolution. This breakthrough has the potential to transform our world in countless ways. It could lead to the development of unhackable communication networks, ultra-sensitive sensors, and powerful quantum computers. The journey into the quantum realm has just begun, but the possibilities are limitless. As we delve deeper into this mysterious world, we are likely to uncover even more astonishing discoveries that will shape the future of humanity.